Welcome back to Math Addict 59, the YouTube channel for the math addicted. Well, mainly me. I don't think too many of you are addicted to math. You're mainly addicted to getting the heck out of math. So now, the reason why compound interest is so important, what you have to understand about compound interest, you're in a situation where you have $6,500. Now, if you're growing it at 7%, you're going to get interest. And then what you have to realize about the interest is that you're going to end up having interest in this case, it's $455. You'll have a new amount. But then when you go to the next year, your new amount would get 7%. You would have to go ahead and calculate that again. And then what happens when you calculate that, you're going to find out you're earning more interest. So your interest actually goes up every year. And over time, your money's going to grow pretty fast. If this were just 7% interest, simple interest, your money would grow 70% in 10 years. But with compound interest, it would actually grow in 10 years to double instead. Now, this problem calls for 25 years. Now, another thing to consider is the fact that we're talking about compounded quarterly. Now, when you're compounding things quarterly, what's really happening is that you're taking 6,500 and then you're having to divide the 7% by 4 because that's a fourth situation. Now, that would give you a balance after 3 months. And you could repeat this 4 times. And then what's going to end up happening is when you repeat this 4 times, you're actually going to get an amount that's higher. Yeah, try to recall how much you had. Now I'm just rounding things just to show you a thing or two. I'm not really, these aren't going to be completely exact, but I'm more interested that you know the concept. So just make sure you realize that if you're compounding quarterly, your money's growing a lot faster. Now you might be thinking, where did I get this from? That came from that whole expression in regards to compound interest, where I'm taking the 7% rate and dividing it by 4. Now everything's happening in the first year, so I'm not necessarily using the formula, but after a year, this is 69.65. Whereas when I did it the old way a minute ago, compounded annually, that was 69.55. So more money came out of compounding quarterly than it did from compounding annually. Just a thought. Now to solve this, now that you understand compounding a little bit and its effect on balances, let's go ahead and worry about the formula. And once again, I'm going to clear all drawings. Now, when I use the formula, I'm taking P, which is the principal. And the principal on too many of these problems is the initial amount given. Now, there are going to be problems where they're going to give you the final amount and you have to go back and find the initial. And that's going to be a different math problem. So we're going to take 6,500. Now, in this case, R is 7%, but you cannot put this in the formula as 7%. You have to write it as a decimal. And you might recall 7% as a decimal. You take the decimal and you go to the left, to the left. It sounds like a Beyonce song. So that's going to be 0.07. Now, because of the compounded quarterly, N is equal to 4 years or 4 times. And then the exponent is going to consist of 4 times 25. Now, once again, and shortly, you're going to get a little calculator lesson because these things are not terribly easy to put into the calculator. You might consider simplifying, but that's up to you. Like you might take 0.07 divided by 4 and get 0.175, and you might want to take 4 times 25 and get 100. Now that's up to you. You might think that's not as easy. Well, what happens when the rate gets tougher? Anyway, I'm hoping this next screen shows up. It's my camera. And sometimes the camera takes its sweet time. Now, if I want to put that problem into the calculator, my strong advice would be just go ahead and type it, but you need to use things like the fraction button. And then put your amounts in the fraction button like 0.07 and then divide by 4. Now, to close out the parenthesis, you do need to press this arrow and then press your parenthesis. I'm hoping this helps a few of you because I know it's tough to learn math in remote, and especially when videos struggle to make. You need to find the exponent key, which is actually, it's kind of glary. I'm having a hard time seeing it, but I'll tell you that the exponent key is this key. It's a caret. So you need to press the caret key, and then you need to type in 25 times 4, or you could just type in 100. You have to put it in a situation to where your exponent is grouped. There's too many calculators which won't put the 4 up there. It'll actually put the 4, it'll actually take the exponential and multiply the whole money amount by 4, which you don't want. Now, like I said, you might want to just consider just simplifying 25 times 4 and putting 100. But that's up to you. But regardless, your answer, this is the amount in 25 years. And this should also help you understand the whole value of investing. Like if you have $100 to put away, I would put it away as soon as possible. See, that's $36,843 and a penny. But, you know, there's a coin shortage, so they might keep the penny. Yeah, sure. They better not. I want that penny because that penny grows too if I let it keep growing. So that's a situation involving the compound interest formula. So here's another problem. Actually, it's the same money situation, but let's say we found a mysterious investment account that pays you compounded continuously. Now, of course, in the real world, most investment accounts don't involve E. However, in many cases involving population growth, biological growth, E is a very convenient way to describe continuous compounding or compounding that you can't really define as happening over a specific time period. Now, in this particular compounding, this is going to be the most maximum amount of compounding you can do. And it's going to involve that magical number E we were talking about in another video. So instead of a graph which might look like this, where the money's compounding quarterly, and then the money goes up sequentially, this situation involves just a straight curve. Because you could think of it as if money were compounding every second or millisecond, and that growth is going to be expressed as a curve, not as a bunch of line segments. So going to how to work this problem, once again, you have an initial amount, which is 6,500. And once again, you have a rate of 0.07. And once again, I cannot emphasize, you have to put it as a decimal, or you're going to get a big wrong answer. The time is 25 years. So the math problem is going to be 6,500 times the exponential raised to 25 times 0.07. And that's how I'm going to go ahead and write it here. Now, you might recall the last answer was 36,843. See, that was what we had before. Now, we're going to look to see how much improvement we're going to see in this money if we compound it continuously. So once again, I'm going to go to my handy calculator. Now, when you do the, hang on, let me make this look a little better. I'm not going to lie, it's just kind of glary. Maybe I'm going to turn off the light. I don't know if that helps, but probably not. But just note that you need to press this button followed by this button if you need second LN. So we're going to put 6,500 and then we're going to put second LN and then we're going to put 0.07. And then as long as I'm in the exponent, I can go and put 25. Now that's still going to be 0.0175. No, it's going to be 1.75, but I'm just going to leave it like this. The answer to this is 37,404. You make a little more money if you were compounding continuous than if you were compounding quarterly, but not a whole lot more. There's not a drastic difference, but it does show you that the more you can compound a bank account, the better you're going to be in the long run. And remember, the reason why you want to invest is for long-term growth. You might get lucky and buy GameStop stock last year and get a huge gain this year, but you wouldn't have known that last year. So don't let some of the fluctuations necessarily fool you. And also remember, I'm not securities licensed, so don't take any advice from me on investing. Just take math advice and follow the math advice. That takes care of this video. Make sure you subscribe if you want to see more videos. And I'll make sure if you have requests for more videos, contact me on Canvas, because more than likely, if you're watching this, you're one of my students. Thank you very much. And it was great having you again on Math Addict 59. Oh, did I write the answer? Oh, the answer's there. I'm not going to worry too much. Okay, that does it.